The graph shows the relationship between the speed of a car and the time spent traveling. Use the graph to answer the following questions. At what speed is the car traveling at 3 minutes? So if you look at 3 minutes, you can see the speed in miles per hour on the y-axis. At what speed is it traveling at 5 minutes? And you can see that speed on the y-axis there. At what time is the car stopped? Is the car's speed ever 0? How many minutes does it take the car to increase its speed from 15 miles per hour to 30 miles per hour? Well, it started at 6 and it's at 30 miles per hour at 8 minutes. So it took it 2 minutes to increase its speed. How many minutes does it take the car to decrease its speed from 45 miles per hour to 15 miles per hour? Go ahead and answer all 5 for your warm-up. Number 1 says sketch a graph based on your partner's description of each of their Sketch My Graph cards. I'm going to describe to you the graphs, and then you're going to try and draw them on your own. For card A, there is a positive initial value. It begins by decreasing and then increasing. It is non-linear. It does not touch the x-axis, and it creates a curve. For card B, it has an initial value or a y-intercept of 0. It begins by increasing, then it remains constant, and then decreases back to 0. For card C, we have a positive initial value. It decreases linearly to 0, and then increases linearly from 0 . Card D is linear. It begins with a positive initial value and is decreasing. Once you have the 4 graphs sketched, check back to see if yours match the description that I gave you, or if you would have needed more detail to be able to draw a better graph. Now we are going to read some descriptions to put them in context. We're looking to match up a graph from A, B, C, and D with one of these descriptions. So let me read the descriptions aloud to you, and you can decide which ones go with which. Number 1 says, Dylan checks the amount of gas remaining in the tank during a road trip. Do any of the graphs A through D match with that description? Number 2, Eve walks to the diving board, climbs up the ladder, walks to the end of the diving board, and dives in. Number 3, Liam realizes that he has left his science project at home, so he walks home to pick up his project and then returns to school. Number 4 reads, Nora places her dog in the bathtub and fills the tub with water. After bathing the dog, she completely drains the water out of the tub. 5, Sarah jogs at a constant speed for a while and then slows down. And last, number 6, Henry likes iced tea hot, but he does not like room temperature tea. Number 6 matches with graph A. He heats it up, and as it's cooling off, he doesn't like it to be cooled, so he would heat it up again. In this one, we would label the x-axis as the temperature, or as the time, and the y-axis as the temperature, so it cools down and goes back up if he heats it up again. Or you could label it as temperature here, and then his level of how much he enjoys it. He doesn't like it too cold. No, he does like iced tea and hot tea, but he doesn't like it in the middle. Card B could match with the description about Nora's dog. She places the dog in the bathtub, fills the tub with water, bathes the dog so the water level stays the same, and then completely drains the tub. For card C, we could be talking about the distance from home. Liam realizes he left his science project at home, so he goes home. The distance to home is 0 here. And then he has to leave from home and walk a distance away from his home towards the school again. Card D could be related to Dylan's distance and the amount of gas remaining in the tank. The more distance he drives, the less gas he has in his tank. For problems 3 and 4, sketch a graph to match the description. Remember to label the axes. Eve walks to the diving board, climbs up the ladder, walks to the end of the board, and dives in. So as time is passing, her height above the water may change. At the beginning, she's on the diving board, walks to the diving board, climbs up the ladder, walks across the diving board so her height doesn't increase, and then she dives into the water. Mr. Jacobs makes chili. The level of satisfaction eating the chili is a function of the amount of chili powder Mr. Jacob uses. So this is the amount of chili powder, and that is his amount of satisfaction. So if he doesn't use any chili powder, he's probably not going to enjoy it very much. And if he uses too much chili powder, he's probably not going to like it either. So somewhere in the middle, there's a sweet spot of the amount of chili powder that he would like for his highest level of satisfaction. For problems 5 through 11, use each equation and its corresponding graph to answer the questions. Y equals x. Does the relationship given by the equation and the graph represent y as a function of x? Explain. Yes. If we replace x, a value, into x, we only get one y value that would make the equation true. So it is a function. B asks if the relationship is a function, is the function linear or nonlinear? Well, this is a straight line, so this is linear. 6. Does the relationship given by the equation and the graph represent y as a function of x? Explain. Yes, each input only has one output that would make the equation true. Is the function linear or nonlinear? Explain. It is linear. Again, it is a straight line. You can also see that it's written in what's called standard form for linear equations. Does the relationship given by the equation and the graph represent y as a function of x? Explain. Again, yes. Every input is assigned only one output. If this relationship is a function, is the function linear or nonlinear? This is nonlinear because it is not a line, it is a curve. Does this relationship given by the equation and the graph represent y as a function of x? Yes. You can say that it has one input for every output. You could also describe that it passes the vertical line test. If you don't want to keep saying the same thing over and over again. Then, is it linear or nonlinear? Well, it is not a straight line, so it is nonlinear. We see this little swoosh right here in the middle, so it is nonlinear. Does the relationship given by the equation and the graph represent a function? No. If we substitute a number into x, more than one y value makes the equation true. You see here, if we put in 3, the y value here and the y value here would make the equation true. That would also mean that it fails that vertical line test. And then it says, if it's a function, is it linear or nonlinear? Well, it's not a function. And it's also not a straight line. Is this a function? Well, yeah, it does pass that vertical line test. It only ever touches at one spot. Is it linear or nonlinear? These are not straight lines, they are curves, so it is nonlinear. And 11, is this a function? No, it fails that vertical line test. And then it says if it's a function, is it linear or nonlinear? This is not a function. Here they've broken down the equations that do represent functions and the ones that do not. Whoop. You may see that these both have a y squared term, which could be contributing to them not representing a function. All of the ones that do represent functions have y to the first power instead of y to the second power. So to classify it as a function or not a function, each input has to have one output. To determine if it's linear or nonlinear, we're looking for whether it is a straight line or not.